This is Nicole Eidenberg. I am a squad leader at Fidelity Investments, and I've had the opportunity to take the Managing Machine Learning Projects course at Duke University. Today we've been tasked to create and choose a problem that could be of interest and where there's an opportunity for machine learning to help with this solve. So today what we're going to walk through is the opportunity evaluation, the CRISP-DM business understanding, the solution validation plan, the ML system design, and potential risks in production. So today, this is the problem statement. So service providers such as business internet, phone service, and networking that use equipment that are installed in homes and businesses which provide a service. So essentially what we call that is a cable provider. So today, customer or business services that get interrupted always require a phone call, and potentially a technician may have to be scheduled to come out to the establishment to be able to take care of the failed device or to help and assist with the customers. So can we use machine learning to predict these types of failures, i.e. weather, upgrades, new software available, etc., to be able to avoid the disrupted service? So in the opportunity evaluation, is there a problem? So if there is, it's usually customer satisfaction. If low, it can impact both the retention of that customer, but also revenue impact if that customer were to leave the service provider. So how and can machine learning help solve or mediate this failure or satisfaction? So all the devices are connected to the service provider, which should enable data collection. The data collection over time could prove out correlations to performance and allow for ML models to predict future trends. So does someone or the service provider care? The consumer and service provider should care about the quality and the satisfaction they provide. Consumers benefit from the uninterrupted service, and service providers keeps high satisfaction, which yields to the bottom line of the P&L. So for CRISP-DM, we're defining the problem. So the target user. So it's twofold. So it's companies that service customers with equipment, and then the customer service department, those that actually run reports on the equipment needed and accountable for setting up the technicians who provide service to the customers. The problem statement, okay, customer service, when equipment fails or needs replacement, it requires a technician to assist. Those types of services take several days or weeks to be scheduled, which leaves the customer without service and low satisfaction. Why does it matter? Customer satisfaction, if a customer is unhappy due to an outage, he or she can go to another provider. How is it solved today? The customer has to initiate a call or a web application to log the issue and schedule an appointment. So currently, there are gaps in the current state. So service providers are not proactive to replace these devices. They are reactionary, causing disruptions to the customer. Defining the success. So what are the constraints? Proactively replace devices that have failed or need an upgrade, which results in a positive customer satisfaction. Some of the outcome metrics, the number of customers that leave the service provider each month or quarter and perform a performance test. Customer satisfaction, or some people call it the Net Promoter Score, again, each month or quarter, and perform a percentage calculation month over month or quarter over quarter, whatever time frames you have. And then for the output metrics, take a look at the error metrics, the precision, recall sensitivity, precision recall curve. Okay, to continue on the constraints and relevant factors, the constraint, probably a new device does not fail. Potential relevant factors, data on the type of failures on the devices. Data or analysis on when devices are used, i.e. are they certain times during the day that there's high usage, and there are certain reasons why there is a higher use. Collection of the data on the type of failure the data has. So the solution validation plan. Solution idea and how ML can be leveraged. The product is the application that will generate reports with various information about the customer. So for instance, the phone number, address, etc., and what device is expected to fail. The ML model would collect this data by using the ability to connect to the customer's device or devices. The ML model would be able to predict which and when a customer's device may fail or needs to be upgraded. Validations on the proposed solution. Create a list of devices and various attributes to be able to group them. So i.e. for a modem, you would want year, model, brand, and other pertinent information that can be used in the model. It then would build an ML model that can generate this list by the various categories. Once a device fails, the model can be updated and be able to repeat this process. The design of the ML would be cloud-based because all service providers' devices are connected to the internet. Offline learning, potentially have historical data that can be loaded to the ML model. And then we would have batch prediction. Service providers needs a list of devices that need to be replaced so that service can be scheduled and ensure there is plenty of product. Lastly, what's the potential risks in production? So the ML model will need to be retrained when new versions of the devices are created or when any new device is now being offered. And also privacy concerns, i.e. we need to make sure we don't breach our customer account.